Well, welcome back to my channel. So today I'll be going through PSLE 2024 question number 33. So Raj know that the amount of light can affect the size of the tiny opening found on leaf. Okay, this one is a key information given to you, and this is related to part C. Okay, so part A is just state the function. Okay, so of the tiny openings found on leaf. So what are these tiny openings? These are actually your stomata. The tiny openings is your stomata. So in the textbook term, right, they will just call it tiny opening, but you have to know that the tiny openings actually means the stomata. So this is a very direct textbook answer. So basically, to carry out gaseous exchange, okay, between plant and its surrounding. So what are the gases that are involved? Okay, so will be your oxygen, carbon dioxide, okay, and mainly your water vapor. Okay, these are the three main gases that are involved in the gas exchange between plant and surrounding. So another answer will be your to allow gases in the air to move in and out of the leaf. Okay, so this is a textbook answer. So you can more or less relate this to this new textbook over here. So the answers can be found on P4 textbook, page 6. So there are usually tiny openings on leaf so that the gas in the air can move in and out of the leaf. So this part over here, right, is really the function of the tiny openings. Okay, so let's move on to the next part. Okay, Raj carry out an investigation to find out if the pollutant S can affect the size. If pollutant S can affect the size of the tiny opening. So this one is your change variable. Your measured variable is over here, and it's very clearly labeled in the table as well. Change variable, measured variable, they are done in 3 different towns. Okay, they are located near one another. This is a result being shown. State the effect of pollutant S on tiny openings, on the size of tiny opening. So basically, this is asking you for a relationship. This is a relationship question. Okay, so you can see that the information is packed in the form of table where you have the change variable on the left column and the measure variable on the right column, and the towns is just to give you additional context. So one way to look at this, right, is to read from top to bottom. So 531. So 531, when you read it down this way, so the number getting smaller and smaller, right? So decrease. So you could write something like as the percentage of pollutant S in the air decreases, what happened? The average size of tiny openings, okay, 356 increases. So this could be one way. Okay, so as the percentage of pollutant S in the air decreases, the average size of tiny opening increases. So this one just use directly the phrase that has been given. Okay, don't go and change or modify the phrases. Okay, this will be the best way. Okay, let me use a highlighter. Percentage of pollutant S in the air. So the measure variable, average size of tiny opening. Okay, so this part pretty straightforward. Or you can do it this way. Okay, you see that this part over here, the number is larger, right? Then the tiny openings is smaller. So then when the percentage pollutant S becomes smaller, the tiny openings become larger. So it tells you that the greater the percentage of pollutant S in the air, the smaller the average size of the tiny openings in the leaf. Okay, you can do it this way as well. Either way will be fine. Okay, the greater the more S in the air, the smaller the size of tiny opening. Basically, this is what it means. Okay, to ensure a fair investigation, the size of the tiny openings on the leaf in all 3 towns were measured at the same time. Okay, this one you have to look at the hint that has been given earlier. So know that the amount of light. So now the change variable is your your change variable is your percentage change in pollutant S. Obviously, the pollutant S in the air in terms of percentage. Your measure variable is your average size of tiny opening. Your fixed variable is the one that you must keep constant so that it will not affect your measure variable, because you want your measure variable to be affected by your change variable only to ensure fair. So your fixed variable is the amount of light, because as mentioned earlier, why this must be kept fixed is because he knows that light can affect the size of tiny opening. If he don't keep it fixed, the tiny openings will be affected mainly by the light and also the amount of pollutant S. So when he do the investigation, he cannot know that the differences is due to the pollutant S or indeed due to the light. He can't make a conclusive relationship of that. So in order to make a conclusive result, he must keep the amount of light constant. So imagine if you have another row over here, amount of light, then this amount of light maybe is 10 units, 10 units, 10 units, okay, across all three towns at the same time, right? So they are all at the same time because they are very near to each other. Then from there you can make a conclusive result, because when this is kept the same, this one is changed, there is indeed observed differences in terms of the size of tiny opening. So in this way, there is quite a few ways to write it. Okay, you can say to ensure that the fixed variable, so you plug this in, remain the same does not affect the measured variable, which is the size of tiny opening. Or you can say that to ensure that the changes in the measured variable, which is the size of tiny opening, is only due to the change variable, that means the amount of pollutant S in the air, and not due to the amount of light. Okay, so let me show you in terms of writing technique one. This is what you can do to ensure that the amount of light cast on leaf. This is the fixed variable. Okay, or this is the hint has been given, remain the same throughout and does not affect the size of tiny opening. Okay, this is the measured variable. Okay, so if you want to add on, it'll be as different time of the day have varying amount of light shining on the leaf. So you want to do that at the same time to make sure that the light remains the same throughout. Okay, when he's doing the test. Or another way you can do it is using this option. Okay, this is usually more for control when you're writing for control, but you can also use this for this question. Okay, to ensure that the changes in the average size of tiny opening in the leaf, a measured variable, is only due to the percentage change in the pollutant S in the air. So this is your change variable and not due to the amount of light cast on leaf. So this is your fixed variable. So this is one way to write it. It's a bit lengthy, but so this is how you can really fully address this question. Both ways are fine. Okay, so okay, let me just scroll through this part so you can take a moment and read through the answers. Okay, so part A, part B, and part C. Okay, that's all for this part of the video. Thank you very much.